We're going to continue with some problem solving today. Specifically, the problem solving we're going to do today is going to involve percents. Okay, everything, in fact, we do today is going to involve percents. And I may be approaching this from a perspective that you haven't seen before. It's definitely possible because this isn't the perspective that I learned it from. But I think that it works extraordinarily well. And so I'd like for you to give it a chance as I'm talking and working with you today through this and see what you think. If you absolutely hate it and you want to do it the way you learned before, I'm not going to tell you you can't. That's okay. But this is the way I'd like to show you because I really think it works very well if it's something you've struggled with potentially in the past. All right? So to start with, we're going to talk about what percents actually are. The word percent actually comes from the Latin word meaning per hundred, as in our cent, like a penny, which is worth 1/100th of a dollar. So when we write down n%, we mean n out of 100. So 30% would mean 30 out of 100. We can use proportions to work with percents, and that's how I'm going to structure what we do today. A proportion, which we have seen before, we haven't talked about it at length, but I know you've seen it before, is actually considered to be two fractions set equal to each other. That's a proportion. We're going to have a part of something compared to the whole of something, and that will equal the percent compared to 100. So like box this in, star it. Every problem is going to be set up as a proportion today. Every single one. Like I said, it's not the only way to do it, but it's the way we're going to do it today. Okay, so the early on ones, setting them up as proportions might feel a little counterintuitive, especially if you do remember another way to do this, but as the problems get more challenging, this structure gets more user-friendly because it works so nicely for all of our problems. So let's take a look at some real straightforward ones. The first one says to find 23% of 30, all right? So I'm going to set up a proportion. The proportion is always going to have a 100 on the denominator of one of them. If it gives you a percent in the problem, which this one does, that value will go on top of the 100, okay? So 23 over 100, that's representing the 23%. If we're finding 23% of 30, this is telling us that this is the whole. And the whole goes in the denominator. So our 30 will go down here. The location where we don't have anything written is the variable location that we're looking for. So go ahead and put whatever variable you like there. Probably going to use x's mostly today. And then we talked about proportions because there were a couple of questions from the last group work stuff that you guys were working with. And do you guys remember what we talked about? How do you solve proportions? Cross multiply, right? So I've also heard it called a butterfly. You like that? Looks like a butterfly maybe. So we're going to multiply across the diagonals. We're going to multiply across the equal sign diagonally. So x times 100 would be 100x equals. And then you're probably going to want a calculator today. So grab it out if you have one. 30 times 23. What is it? 690. Fantastic. And then what would we do to solve for x? We'll divide by 100 on both sides. And what is 690 divided by 100? 6.9. Okay, so we're not going to round unless we're told to. We're not going to leave things in fractions here. That's not going to make any sense at all for percents we're looking at, okay? So I know you guys are like, woohoo, don't like those fractions anyway. But yeah, so 6.9, that's our answer. Okay, so take a look at the next one. 70% of 59. See if you can set this up. Take a second to write it down. Don't solve it, just in case you don't quite have it right. Go ahead and set it up. Okay, so you should have a proportion like this. The 100's always going to go on the bottom. I always put it on the right. Doesn't really matter, but I put it on the right. What else goes where?
The 59 goes on the denominator on the left side.
Okay, so the 59 goes here because this is telling you that this is the whole, right?
And then 70's over the 100.
Right.
X is in the other. Yep.
Perfect. You guys get that? All right, so let's do our diagonals. So one of my diagonals is, again, 100x. That's not always going to happen, but what is the other diagonal's value going to be?
1,130.
That's right. Thank you, Keely. 4,130. And then what? Yeah, divide by 100.
41.3.
Perfect. Okay, so like these problems don't really have context, right? They're just a very straightforward, this is not a word problem. I realize there's a few words in it, but this is not a word problem. You guys with me on that? Okay, we're gonna do a couple more like this, just getting comfortable and familiar with the setup, and then we're gonna get to some legitimate problem solving in a moment. Okay, this problem is worded differently. Can you tell what it is that's different about this problem? Where? We had that before. There's something else. Ooh. Okay, so this part says the what number part here. How is that going to mean the problem is set up differently? Like, what's going to be different when I actually set up my proportion because of the structure of the English? Yes, it will. So this is actually a part. It is part of what number? Do you guys see that? The part that says at the end that says is what number, right? It's 60%, it should say of. No wonder it looks bizarre. That should say of. It says of in my notes. Typo. Of what number? It's the part that says the part at the end that talks about that of what number tells you that that's what you don't know. You don't know the whole. The 60 actually is in the numerator. The other part's the same. Always going to have 100 on bottom. The percent they give you, 53, is always going in the numerator of the 100 side. And then once we have it at this point, of course, the problem solves the same way, cross multiplication. So we're going to have 60 times 100. What's 60 times 100? Good, 6,000. And then I have x times 53 for 53x. And then what would I do? I would divide by 53. I actually feel like that I probably didn't get this problem changed right with what's in my notes, but that's okay. We'll just go with whatever it is. Okay. What is 6,000 divided by 53? Because that's definitely not what's in my notes. Okay. It's an ugly decimal that doesn't end. So you won't have any of the ugly decimals that don't end. So for what we'll do right now, let's just put 2 decimal places and go with it. I don't want to fix anything else. 113.207, so 21. I don't even know where those numbers came from. I have no idea what's going on. That's okay. We'll keep going. 4 is exactly what's on my notes, so that's good. All right, 4. How is 4 different than the previous problems that we did? We don't have the percent. So the part that I don't know is actually the value over the 100. Right, Megan? Yeah. Okay. What numbers go where?
76 is right.
The 80 goes in the denominator, and the 76 is over the 80. You got it. 80 is the whole, 76 is the part. And we are going to cross multiply. 76 times 100 will be 7,600. And then I have 80x. What's next? Yeah, divide by 80. So what is 7,600 divided by 80? 95. And oh, somebody even said it so fantastic. It's percent, right? We need that percent sign on there. We are asked for what percent it is. It is 95%. Okay. Are we kind of okay? Everybody pretty good? Awesome. Because now we're going to do the ones that actually have context to them. Some of them are more obvious examples. The first ones, I think, are. And there's going to be a couple toward the end are going to look a little less obvious, but they work the same way. Okay, that's why they're all in the same section of material. All right, so here's Scott. Scott's apparently running. Maybe he's our long distance runner from our last assignment. I don't know. He's running on a treadmill, which let me just tell you is horrible if you're running long distances. He's going to run on the treadmill for 88 minutes. I've done that before. It's awful. I don't recommend it. 88 minutes. The display says he's completed 31% of his run. How long has he been running? And then it says we are going to round on this one to the nearest tenth. What does that mean, round to the nearest tenth? 1 decimal. A few of you are not sure about how many decimals when it said something on your homework, or maybe it was the exam. Tenth is 1 decimal. Okay, so let me give you a second to write all those details in. Okay, so we're going to set up a proportion. Somebody tell me where to put something. How would you start? 31 over 100. Good job. We have 31% we've run out of 100% total. There's one other number in this problem. It's the number 88. What is 88? Is it a part or a whole? It's the whole. He is going to run for 88 minutes unless he quits. But we're assuming he's going to finish it. Okay, so 88 minutes is the whole. The thing when we don't know is the part. What part has he already accomplished? So that's my x. We will cross multiply. So I have 100x equals, and what's 88 times 31? 2728. Good, that's what I've written down too. And then we would divide by 100. Now, this problem actually gives me a terminating decimal. It would be 27.28. But the question's directions said to round in the nearest tenth. So what will my answer be to the nearest tenth? 27.3. And what are the units on what I'm working with? Minutes. You're right, Michaela. Yeah, minutes. He's running in minutes. Could the units be different? It could. It could be seconds. It could be hours. It just depends on the context of the problem. This one was minutes. Okay. Percents are used a lot in stores. Anybody go to Kohl's? Everything's on sale all the time at Kohl's. There's percent signs everywhere. So you might end up with something like this. An item is regularly priced at $95. If it's on sale for 20% off, then how much would the discount be? How much is discounted from the regular price? Is how it's worded. How much do you save? That's how I should have said it. Actually, that's what I wanted to say, but I was trying to mirror the language that's in your notes or in your homework, and so they worded it that way, which I thought was a little awkward, but that's okay. How much do you save? This is an important skill. Do you know why? It is everyday life. And not only that, at some point, you're probably going to be telling someone else, because you're accountable to them for how you spend your money, but I saved $20 on the sweater. I mean, like, you spent $60, but you're going to focus on the savings, right? You guys know what I'm talking about. Yeah. Okay. So again, proportions will do this for us, all right? What numbers go where?
20% over 100.
Good.
And then 95 on the bottom.
Yeah, because the sweater is originally priced, the whole price was $95, and we don't know the discount we're receiving. That's going to be X. Okay, so we cross multiply. So I have 100X. What's 95 times 20? 1,900. And if I divide then by 100, how much am I saving? $19, and I like that you guys remembered the word dollars. That's good. Saved $19. Now let me pause for a moment and just ask you the question. What if it said, how much did the sweater cost?
Subtract 19 from 95.
Yes, you would. At the very end here, you can simply take the 19, take 95 minus the 19, and you'd have the actual price that you're paying for, right? Yeah, and we'll do another problem like that in a little bit. Another example. So again, one of those things that hopefully at some point you will be in a position where you own a home, right? Homes tend to go up in value. That's why people want to buy them. It's because it's worth more 10 years from now than it's worth today if you don't trash the place. So a house, in this case, is a very nice one. It's valued at $388,000. Over a few years, the value has increased by 7%. And the question is, how much did the value increase in dollars? Right? So like if you were to go sell the house now, how much did you make just because you happen to be the one owning that home? Very practical question. Okay then, setting up a proportion. What numbers are going to go where? 7 over 100, good. And where's that 398,000 going to go? This is a tricky one. It actually goes on the bottom, the 398,000, because it's the original 100% price. I know the price is going to increase. I get that. But the 100% is the original price. We want to know what is 7% of that we're going to increase to. So our 398,000 is actually going to go on the bottom.
Right. 388. Yeah.
Oh, did I say it wrong? I'm sorry. Thank you. Yeah, and that's what it is in my notes too. I wanted it to be worth more apparently. All right, and we don't know what the numerator value is. Okay, so I have 100x. 7 times 388,000 is quite large. What do you guys get when you multiply it? 2 million.
716,000.
Right, 716,000. Good. And then we'll divide by 100. So what is 2,716,000 divided by 100? $27,160. Now, that's how much more it's worth after those few years. And this is why people want to buy homes, is because they're anticipating and expecting that increase. You all right? Okay. They're anticipating and expecting that increase in price, right? Increase in value, actually. And it is dollars. So it's worth $27,000 and some change more now than it was when they bought it. It's pretty cool, right? Yeah. And I don't know about you, but when you see 7%, you probably don't think of that as being a very big value, but 7% of such a big number is a big value. Because I don't know about you, but if somebody just wanted to give me $27,000, I wouldn't say no. Right? Yeah, okay. All right, let's try another one. We're going to go back to our sales, our shopping experience over here. Here we have an item that is priced at $53 originally. And DeAndre is going to get, man, a whopping big discount, 95%. Nice. Now this question's different. This question wants to know, how much did DeAndre pay? I want to show you two different ways to do the problem. Okay? So, for starters, if you were anticipating how to do the problem, tell me what you would put where. I'm not trying to trick you, I promise.
95 over 100.
Okay. 95 over 100.
53 over the x.
Okay. Still, the original price is 53. Yeah, so it's still 53 in the denominator. X will be the other unknown value. Okay. So this is 100x equals, what's 95 times 53?
5,035.
Okay. And if we divide it, we would get 50/35, like that. What did we find? We found what, Jack? How much he saved. And so what did you say, Connor? Yes. We would need to take the original price minus the savings that he had. On this problem, this is how much he saved. So what is 53 minus 50/35? 265. Have you ever gotten that good of a deal on something? It's a pretty good deal. I've gotten some pretty good deals before. I'll have to tell you sometime about how I used to grocery shop. I used to get free stuff all the time, literally free. Okay, I want to show you another way to do the problem though. Okay, so somewhere along the way you have to be really careful with this type of problem. Either it's at the end, like the problem we already did, like the pattern we did in this problem, right? Where you have to make sure that you're answering the question that's asked. When we get to the end, we have to make sure we answer the question that's asked. Or you can make sure that you're doing it at the beginning. So let me show you one other way to do the problem. What we could do when we set up x over 53 is we could set it up so that it's actually 5 over 100. If he's saving 95%, then he's paying 5%. Are you with me? So we could take into the consideration at the beginning instead of at the end the fact that we're paying 5% as opposed to saving 95%. If we work through the problem like this, we're going to have 100x. It's going to be 53 times 5. So 53 times 5, I think I have it written down. Where is the problem? 265? Yeah, I was on my wrong problem. 265. And if I divide by 100, the beautiful thing on this way of doing the problem is that the answer is actually, that you get is actually the answer to the question you were asked. Because you sort of preemptively looked at the setup in terms of what you're paying versus saving. It didn't make any difference which way you do it. You just have to be careful that somewhere along the way you're answering the question that's asked. Okay? Okay, let's try another one. More sales on clothing. And didn't even say clothing, but you know, that's where my mind goes. So an item on sale has been reduced by 40%. It was originally $90. What is the sale price? Okay, so this is the same type problem that the last one was. Same type problem. So let's pick one way. I don't care which way we pick. What do you want to set up? What numbers will go where? 40 over 100, okay. X over 90. So because I'm doing 40 over 100, I need to remember that this is my savings, right? It's not how much it's costing me, it's how much I'm saving. So let's cross multiply. 100x equals 3,600. What would x be? 36. So it's $36 in savings. So what would I do to get how much it actually cost? Yeah, it was 90, I think, wasn't it? 90 minus 36 would be, that would be $54 is my cost. You don't have to write the word cost, but I just want to make sure I'm clarifying with you. Okay, now, did you know that when you go to the store and you pay $54 for this reduced price item, that the store is still making money? You know that, right? Like even when they discount it, they're still making some. They're not making as much, but they're still making money, right? So their ability to do that is based on the fact that they have what's called markup. So markup is when the store purchases it at a wholesale, it's called wholesale pricing, right? So, Kohl's is going to purchase clothing from all these different retail, like people who make the clothing at a certain price. And then they turn around and they are going to make a profit because they're going to sell it to you at a higher price, correct? That higher thing that they're finding is actually called markup. So here's an example. The wholesale price for a particular pair of shoes is $3.50. Like that's what Kohl's pays whoever for the value or for the pair of shoes. The store is going to mark the price up. In this store it says by 80%. And we would like to find the price of the shoe when you actually buy it in the store. Shoes. How much is it actually going to cost when you as the customer purchase it from Kohl's? I don't know why I'm picking on Kohl's. I don't know. Maybe just because they like to do discounts like this. So here's the thing. It's not talking about sales. It's not talking about values of houses, right? But it's still percents and proportions. So it still works the same way. We can still set up our proportion. What's going to go where? 80 over 100.
And then $3.50 above.
It is. The 350 is still the 100% price. We need to know what the 80% markup is. So it's still x over 350 equals 80 over 100. So let's take a look. I have 100x equals, I wrote down 280. And if I divide by 100, x is $22.80. Did I find what I'm looking for? Am I going to pay $2.80 for those shoes? Yeah. This is the profit, right? This is the part that Kohl's gets to keep after they actually paid for the shoes and you paid them for them. So the cost for the shoes is actually $350 plus the $280 for a total of $6.30. Is that right? Yeah. They're probably flip-flops, I'm just saying. Like, I don't know any other shoes that I'm going to get for that price. Probably flip-flops. It's probably not Kohl's, it's probably Walmart at that price. All right, I have one more example for you. We have just barely enough time left. TVs. Well, actually it's sales tax, but it's a TV. So we have a TV that's listed at $731.99. The sales tax is 7.75%. Find the total cost of the TV. So one more time, I know there's other ways to do this problem, but I want to show you that we can do proportions for all of these types of problems. So here's the cool deal. Proportions, they're wonderful. What values are going to go where? $7.75 over 100. Looks good. Yeah, that is the whole 100% price. Okay, the tax is an add-on price, right? Just like the wholesale, the markup is the add-on price. So if I cross multiply this, 100x equals, this is a horrendously ugly number, so I'm going to write it down for you. It's 5672.9225. And when I divide by 100, I move the decimal. So it's 56.72, whoops, 9255. This is money, so they don't really need to tell you to round. You know you have to, right? Like our coins stop at the cent, so we have to round to 2 decimal places, and we will round this one up, so it's $56.73. What is the $56.73? That's the tax. Is that what I was asked to find? Right, so we're going to take our $731.99 plus the tax, $56.73. For our grand total that we're actually going to have to pay for, right? $788.72. Okay, it's a ripoff. Thank you. What do you guys think? Proportions. Maybe not how you would have probably thought to do these, right? But percents can always be set up that way, which is really very friendly.